So our speaker today is Ray Severon. That's it correctly?
Sure.
That's close enough. Very gracious guy.
Hey, good morning. Ray Severon. I'm with Nokia. I'm part of the Nokia Enterprise team. It's part of Nokia most people initially don't know about, but Nokia has a enterprise division, really legacy Alcatel-Lucent and Bell Labs, and parts of Nokia Innovation. And my area of focus is on private wireless. And my role is to actually develop partners or customers, use case, ecosystem, and really find purpose for and drive the what we're calling the Industrial 4.0. For example, Airwaves. We worked with Airwaves in Dallas here. They were the first private LTE on a DAS. So we deployed their DAS system, and we added private LTE for non-carrier operations within the building so that they can add operational. And what I want to try and focus and talk about today is a few verticals at Nokia. What we've, I guess, discovered in our go-to-market is that IoT and private wireless is vertical specific. Enterprise do not necessarily buy connectivity. What they buy is a use case. They buy a solution, a purpose for their operational needs, and we're kind of focused that way. So I'm going to go through some of these use cases. I'm going to pick a couple of verticals today, but I do want to go a little bit and talk about our view, anyways, of the Industrial Revolution. We're in the middle of it. I mean, it may not seem like it from the promises of some of the consultants have come out and say it's going to be 40 billion connectivities and it's going to be. But we view that we're already part now. COVID-19 kind of slowed down some of the verticals, but actually accelerated other ones. It's been kind of an interesting last 6 months to see the shift in different verticals that have been implementing these. And why are they implementing new digitization, digital transformation, IoT solution? For most verticals, it's a competitive edge. They're looking for that competitive edge. So one of the issues around private LTE is the concept of, is that to replace Wi-Fi? Or is that to replace the carrier network? It's not. It's a unique connectivity solution to address a certain segment. That doesn't mean that you won't see it in the other areas, but really the private wireless in itself is not really new. We've been doing it in Europe with rail for decades. They call it GSMR. It was even before LTE. And the issue has been industry has always needed this type of connectivity, but they didn't have necessarily access to spectrum. And if they did have access to spectrum, they didn't have access to a ecosystem of devices and software that they could scale down or up. What we developed at companies like Nokia and Ericsson and Alcatel-Lucent at the time was for the carriers. We didn't develop solutions for enterprise. So until about 4 years ago, Nokia made a decision, no, we're going to form a separate enterprise division and start developing solutions geared towards enterprise. So our solutions are based on going after business critical applications or mission critical applications in the OT side, operational side. So here are some of the customers, and these are use cases as to they're not thinking about doing it, they're doing it. Meaning these are use cases that these verticals are investing in, deploying. So if you look at the energy vertical, actually the U.S. I think has been a little bit unique in the energy sector, the utilities, in that, I mean, literally 5 years ago, they were going to the FCC saying, we want spectrum. And they were not, and they formed a association, I guess I would call it, to go after it as a industry. They went after it. They were not successful with the FCC, but then thanks to our partner AT&T and Nokia got together and said, well, look, here's some spectrum that AT&T was willing to and wanting to offer to the utilities, and we created a solution based on AT&T spectrum, and it really started the wheels in motion. And this year we're seeing larger deployments now in utilities. I would say within the next 2 to 3 years, most utilities will have their own private LTE network. Why? Automated falling conductors disconnect to avoid fire. One of the biggest deployments that's happening right now is in utilities in California. Why? Forest fire. I don't remember which of the utilities that got sued because they were being responsible.
PG&E, Pacific Gas.
I couldn't remember if it was Sempra or PG&E. So they were viewed as being, the forest fires were caused based on their network, their utility network. So automated falling conductors disconnect fires. It's quite an amazing technology. They can now, when a line goes down and before it hits the ground, communicate, and it can hit the ground, and then they have to shut down sometimes miles of utility poles. Now they can do just sections. As it's falling, they get notified, shut down, and then they can just locate where that line fell. Maintaining grid reliability. This is mostly their FAN network, their field area networks. We also see that in the solar and wind energy, they're deploying private networks. The wind turbine monitoring for predictive maintenance, I think, is an interesting one for me. And this is kind of the role of what Nokia is trying to do right now. Is we went to a wind turbine operator, and they went through their operations with us, and we tried and find areas of high cost for them. And one of the high costs was they would shut down a wind turbine 2 to 3 times a year to go and inspect it, to make sure that the amount of materials, because it grinds, there's steel and other materials that grind and fill in the top. And we worked with other IoT companies to come up with a solution where they didn't have to go and do this and actually send a crew, because it was very expensive to send a crew, shut down the windmill, and the windmill would be down for 3 days, and they'd have a crew of 2 to 3 people inspecting the wind turbine. So we eliminated that by working with sensors, cameras, and an LTE connection, and then be able to reduce their costs of doing maintenance. I'll go into the mining. Mining for Nokia, that's been one of the more advanced, I guess, in private networks. They're deploying it globally, and a lot to do with they have autonomous vehicles. That's part of their operations now, semi-autonomous or fully autonomous. And they were really managing it with their Wi-Fi network as best as they could, and it wasn't Wi-Fi wasn't meant and developed for that kind of application. So they've now moved over to private LTE. They also do we classify as part of the connected worker. They monitor driver fatigue, increase safety with remote drilling. So these are the use cases that the mining industry is investing in private LTE for those purposes. Transportation, like I said earlier, on the rail, it's been done for decades now in Europe, but now we're also seeing the aviation, where they're adding connectivity for the crews. Also, when the planes arrive at their destination, data downloads, adding to the operational side of airports. Pretty much every area of their operations that they had a connectivity need, or what we call cutting the wire, where if wireless wasn't working for them, either the Wi-Fi or they weren't able to do it with the carrier network, they were running a lot of cabling, a lot of fiber, a lot of Ethernet that really didn't make sense in an airport environment. Now they're able to replace that.
Okay, we have a question from online. It's from Solomon Israel. He asked, Ray, from a definition standpoint, do you consider a private network as one where enterprise actually owns the spectrum, or uses CBRS, or leverages network slicing capabilities in 5G to reserve and allocate the needed network resources?
We view a private network in that the enterprise control and manages the network. Now, they may outsource the management of the network. They may outsource the engineering, but the network is within their control. That's why it's a private network. So they can either own the equipment, they could also lease it or outsource from a managed service provider or a neutral host network or a carrier.
So you're given AT&T example. I mean, they operate private wireless networks for all sorts of people, right? They may not own it. AT&T obviously owns the network, but it's a private network and has all the all the benefits, low latency, whatever.
Yeah. To us, it's about the control of it. In other words, they go, I want a radio here, and they don't have to ask anybody. They can go put a radio there. They want to change the quality of service. They say, I want to change the quality of service, and even in a shared environment, that could also be a private network. I think that's our definition. There's no necessarily, it doesn't have to be under CBRS, or they don't have to own the spectrum. It's about who controls the network.
Yeah. Hey Ray, I've got one. So on that, what is the trend looking like? I mean, are folks deploying it themselves, or are they getting like an integrator to do it and manage it for them, or are they asking you guys to do it for them? Where do you see it, and where do you see it going?
I see it based on the skill of the enterprise. So since what's happening with private LTE is also simplification of the network. So now we've developed a solution that's literally plug and play. So the skill level of deploying an LTE network now is more about physical installation and IP connectivity. So if that organization, enterprise, has those skills, they do it themselves. If they don't have if they have to do infrastructure like a tower or installation of the actual APs and cabling, they can outsource it. So, but the trend to me is no different than let's say a Wi-Fi network. If they have the skills, they'll do it themselves. If they don't have the skills, they'll outsource it. And
so do you have enough data points now to trend it? I mean, where is it today? I mean, is it all over the board where some folks are doing it, some folks aren't, or?
Well, I'd say right now it trends more on they do it themselves, or at least manage. They may still outsource it, but they manage the outsourcing. But that's because we're dealing with larger organizations right now. That's at Nokia. So at Nokia, we're dealing with the Toyotas, the Caterpillars, the large organizations that in FedEx, they have those skills or can have access to those skills. Proof of concepts and trials, they usually look to telecom experts to do that. But once they understand the technology, it's about cost. They look at it and they go, hey, we could do this ourselves. How much is it? Yeah, let's do it ourselves. Or, no, we don't have the capability. So I think actually now that private LTE will become more commonplace, it's going to go down to smaller organizations, smaller companies, where I think they'll probably need and want more help from a managed service.
Yeah, thanks.
Give us a sense of what a threshold is to deploy. How large a site do I have to be to deploy this product?
We literally deployed one small cell for an enterprise that had a very specific use case, or we have what's called LTE in a bubble, and for under $50,000 you can have your own private LTE network. So that's again the focus on not just us, by the way. Nokia is a little unique because it's a large OEM, but there's a lot of competition now in private LTE because new companies, Athen, Fortis, Druid, they are small enterprise that scaled down so that really it becomes affordable. And we actually expect within the next 5 years to 10 years, private homes having their own LTE network. I have 5 kids at home and an au pair. I need a private LTE in my home. My Wi-Fi network is can't handle it. So I'm being facetious a little bit, but you start looking at the amount of devices, the whole concept of 5G. If they bring the price point low enough, I think it will be actually even a retail technology. So I wanted to hit the ports too. That's another area that we see a lot of deployments, not just interest, but actual deployments. And again, one of the main use cases we're seeing is AGVs, autonomously guided vehicles. One of the benefits of LTE over Wi-Fi is mobility, handovers, and in an environment of AGVs, the AGVs move within the facility, and usually large facilities, be it indoor massive warehouses or outdoor in the port. So cranes, autonomous cranes is one of the use cases. The autonomous vehicles within the port, and reefer monitoring. And then in manufacturing, manufacturing's been an interesting one from a standpoint of they've shown the most interest actually originally when we look at the amount of companies that are calling Nokia, but they've been slow to deploy. And that has more to do with the manufacturing mindset. They buy an asset, they want it there for 30 years. So they don't shift technology very quickly. Yes.
So we've got another question from online from Tom Zaleski. He goes, from a competitive standpoint to VSAT, I assume advantages include cost, speed, and lower latency. What about coverage in remote areas, particularly mining, gas and oil, aviation, etc.? Can you service those kind of applications?
So coverage, outdoor coverage.
I think he was like mining. And
Yeah. Well, the issue with coverage is spectrum. So if you have access to spectrum, it's a cost-efficient, good technology. But then if you don't, like, I hate to say this because it's really popular right now in private LTE, is CBRS. CBRS we don't view as a rural or large geographical area type band because of you can't change physics. So that's why actually we try to partner with carriers as well, where we do have private LTE networks on carrier spectrum, where they've, we do this actually in mining in Canada. We do very large open pit sand mines, oil sand mine. Yeah. And we partner with one of the carriers in Canada that provides the spectrum on a private LTE network. So I do want to go back to manufacturing. There are very good use cases in manufacturing. We've recently announced our work with Toyota. Toyota's main use case was actually flexibility. They deploy their machinery in these large facilities, and then something occurs and they want to ship that machinery. And it is extremely expensive for them to stop the plant, move the equipment, rewire, because they want to get as much, they're IoT focused, digital focused. So most of the machinery, if not all, is already connected, but it's hardwired, Ethernet or fiber. So being able to shift that machinery and not have to worry about the cost of the cabling and the time it takes, that's their main use case as a large auto manufacturer. Other ones are, and including, by the way, Nokia, we've implemented private LTE and IoT solutions in our own factories. AGVs is another big one, autonomous guided vehicles within the plant, digital twin, machine connectivity. That's actually one of my favorite things. I'm in this role because I love technology, and you get to see some really cool stuff. So we did the NASCAR proof of concept, and we put cameras in the cars. But what was really exciting is actually working with about 4 or 5 different companies that wanted to combine live racing, GT3, GT4 racing, with gaming. So what we worked on was during an actual race, we would also have a gaming event, and you'd have the gamers able to, through digital twinning, race the actual race and have a simultaneous event occur. And which COVID didn't have. Sorry?
You have to have super low latency.
Right, that was the whole point. So edge computing plays a huge role in this. And this is, we worked with experts in that area. Putting the core of the network, the radio network and the LTE network, right on the same platform as the digital twin, you remove that latency anyway.
Yeah.
But there's still work to be done. It wasn't as I mean, this was a trial, so we have some work to do. But the concept to me was really fascinating. That not only could you see, have multiple cameras, and that takes a lot of throughput. Actually, it was the first 5G use case that I witnessed or seen, because you actually need that ultra low latency, you need that high bandwidth, and to me, it made it also more exciting for. There's a live event, but you're merging it with gaming. So I thought that was pretty interesting. Not that manufacturing is going to get into gaming, you're going to play in manufacturing. That's not the same type of digital twin, but I thought that was interesting. In public safety, this to me, actually, public safety smart city is the one that I scratch my head at, because there are so many good use cases in public safety and smart cities, and they're economically viable as well. What they can't seem to do is figure out how to budget them. They're siloed organizations that just cannot seem to work together. I think it's going to break sooner or later, but it just hasn't in this country. I mean, we've done large, huge, massive projects across the world, but I think it's because of the way their economy and budgets and how they structure things. Like Dubai can say, okay, we want smart city applications. We have a really cool deployment in Holland with drones and integrated operations center, and putting all these IoT connectors together, and it makes a lot of sense, and it saves lives and it saves costs. And we're having a hard time in this country to get around that.
But that's the government, right? That's the frustration of dealing with the government.
Yeah. So I just wanted to give you kind of an example too, that where we're seeing people actually spending money. And I think that's one of the, in this room, everybody is in the IoT world, digital transformation, but it's trying to, where are the customers? Who's actually buying this? So we've seen majority is in energy, and again, because of the utility building large networks, that's probably a factor in that. Public sector and smart cities is still a large spend. Transportation in the U.S., mostly in the ports. The rails it's 2-3 years now in the making of doing trials and POCs, and they want their own spectrum, and so there's a little bit of an issue. Though we're seeing, and the other one of interest to me is the light rail. Light rail, there's a lot of good applications in Europe that are deployed. They haven't deployed in the U.S. Again, I think it has to do with government budgeting and initiatives in light rail. And then we're spending a lot of time in manufacturing, even though right now it's still probably one of the smaller markets from a percentage standpoint, but we believe it's just the nature of manufacturing that it's a very long sales cycle for them to implement new technology.
Hey, Rick.
Yeah.
Question. Those numbers in the segment, is that the number of deals or no?
It's just percentage. Just percentage.
Oh, so that's percentage.
Yeah, if I put the percent sign, it screwed the crap.
Got it. All right, thanks.
I was playing around with it last night. And then I want to give you an example of what they're saying. They're macro base stations. These the carriers have deployed globally 7 million radios. The expectation is in the next 3 years, 14 million will be deployed for industry. Now, of course, they won't be macro cells. They'll be probably more small cells. But that gives you a sense of how much will be deployed and in what areas.
$50,000, so how much are they?
Pardon? This is quantities.
I know, but what's typically how much does it cost?
Well, one small cell can go from there are small cell vendors that sell it for $2,000 per small cell, all the way to $20,000, depending on the capacity and the power. But this is the important part, and this is really why I'm here today. Is from Nokia's standpoint, we view that it requires a whole ecosystem. So there's an ecosystem on the carrier side or the public wireless side. Samsung, the devices, the MiFi devices. That ecosystem exists, and we're going to leverage that ecosystem. But the IoT exists. The IoT ecosystem is just starting to evolve now. We want to see that evolve more. Ideas of what you came up with, for a festival or what you do in a plane. It requires software. It requires devices. But more, it requires ideas.
Those are really bad ideas, by the way.
Yeah, but there is no bad ideas. For right now, where we are in industry is new. I mean, I'm working with a partner in California that I love these guys because they're so innovative. They're called Radiant Images. They create solutions for video, mostly, they're in California, so mostly for the studios. So if you see, they figure out how to put a camera on an animal or on a device that they're going to throw over the air, and they love private LTE from a stand, and they did with the NFL. I think they partnered with either AT&T or Verizon. I don't remember who. They did the NFL 5G. Now they didn't bring the technology, but they brought the video aspect of it. So they have now a way to compress data so that you can get a studio can use a wireless camera while the producer and director are controlling everything live on their screen, and they have like 20 different cameras they're controlling, and they're all wireless, high HD. The throughput required for that was massive, but also the flexibility to pop up a network. So the director goes, okay, we're going to film here, everything is ready. Then he goes, no, not today, I moved it. We're going to go film, down the street, and all of a sudden they have to, before it would have been a total panic, high cost, moving all this equipment, trying to figure out how to wire it. Now they can move a bubble, and they can not lose production time. And these are kind of ideas that I really like. Sorry.
So another question from online from Sunil Andani. Do you define in-building wireless solutions as private wireless network? So, distinction between in-building versus private.
It doesn't matter if it's in building or out. The difference is who owns the network, or I should say, who owns the network.
Spectrum.
Who controls the network. That's how we define private, is who decides where the radio and the cord is. Go ahead, please.
When you talk about high definition cameras and NASCAR events, are you using a millimeter wave RF spectrum? Are you into RF2, or where are you at?
No, for neither of those did we use a millimeter. Actually, for NASCAR, we did multiple spectrum, but we'd be. So I gotta be careful. So no, we didn't. We did test one time with millimeter wave, and for radiant, it's not necessarily required. It's probably the better spectrum to use, but it's not required.
Right.
So there are ways to work around it, but you do need a lot of bandwidth spectrum.
So you're within the new like gigahertz spectrum that is out 5G, right?
Yeah, and we have tested. We have access. Like when we work with, because you have to work with the license holder. So for millimeter wave right now, it's all licensed.
Right.
So we worked with the carriers. But for example, Radiant Images is using, they're combining multiple spectrum. They're using our the CBRS, that's free spectrum. They're using Band 53, which is a partnership we have with Globalstar, and they're using the multi-fire.
Okay. Yeah.
Which is not really millimeter wave, it's in the 5 gigs. Okay, so it goes back to the ecosystem. I wanted to talk about this. So what's different about private LTE? Yes, CBRS is a huge change in the U.S. because now you actually have access to spectrum, free spectrum. The other one was simple and easy to use. There was a need for a simplified LTE network deployment capability and stack, and really that's really the evolution of edge computing and also virtual cloud-based software. So this is just our example, but there are other companies that are very similar to ours, where you can have an edge server. We say we have a cloud core solution. Well, that's cloud. You can have it a centralized cloud, or you can have it on the edge at the customer premise. And that's a big driver for a lot of these companies they don't want their core data or their data necessarily on a centralized cloud. They're fine with it being on a cloud platform, but they want it to be on premise. And it has to be simple to operate, simple to engineer, and they don't want to become LTE experts. Ecosystem. This is, to me, not just about devices. To me, it's also about IoT software and the applications and how they can leverage the network. And then it goes back to, what's a private network? It's keeping full control. That's what makes it a private LTE network, is they have control to the network.
Hey, Ray, I've got a little, this is more a sales process question. Sure. So if you go out and hit customers, right, are they already ready with the spectrum, or are you hitting them and saying, well, we got to get private spectrum, and they go, oh, can you help us with that? Just kind of curious how.
Well, the change now in the U.S., CBRS has changed that. Most of them are aware of CBRS, or at least have some understanding of it, so that is changing as we go. When we go, I mean, we work globally, so there are some areas where they don't have free public spectrum, so we have to work with the carriers, and they do ask us, and we have, we work with partners like we did with AT&T here in the U.S. for utilities.
So this is more a U.S. question.
The U.S. question is that they'll, if they don't know about CBRS, then they'll ask, well, what spectrum can I use? And we have to give them the answer.
And is it a big hurdle where you have to wait on that months and months and months, or does it happen pretty quickly?
When access to spectrum?
Yeah, to get
there, you have access now with CBRS. It's very quick, and we have access to other bands like band 53 or 9. There's the 900 megahertz now available. So there's it's not about now, unless they want to, like in Canada, get access to a carrier band. There could be some hurdles there, not just because the carrier may have to request, or like AT&T had to go to the FCC to say, hey, we want to use this spectrum for utilities and get that approval. But right now, in the U.S. there's a lot of available bands that don't take a long time to get access.
And it just happens. It doesn't slow the sales cycle down.
Correct.
Okay.
Just to give you kind of a sense of the type of private LTE networks, again, this is our example, but very similar to other of our competitors. There's the radio side of it, and this is what I was going to, I guess, show earlier. That there's different aspects of it, right? Private LTE radio is not just the radio. So you need the endpoint, you need the devices, and in enterprise, there are a lot more creative devices. It's not necessarily your iPhone or your Pixel. It's what goes into the machinery or the drone or whatever the use case is. You need the radios. You need backhaul. The big secret about 5G to us is not really a wireless deployment. It's all about fiber. So you need to be able to backhaul it. So you have limitations there. Core network, we have the traditional standard, larger, more complex core networks that we've been selling to the carriers for years. And then there's really a new introduction of more of an IT, I call it more of an IT type software solution now, the virtual solution, which is a cloud solution that integrates everything and makes it very simple to run an LTE network. And then there's the apps. So go back to and then it gets distributed in multiple ways. There's the private aspect of it is the bubble, the wireless bubble. And you can recreate that bubble whatever size you want or how many you want. You can manage them remotely, you can manage them locally. It's really, there is one issue in the US, is that if you're using CBRS, you have to use a SAS, which to me was actually a very good idea that came up, was that if there's going to be free spectrum, we don't want to evolve to the same thing that happened with Wi-Fi, where anybody can turn up a Wi-Fi network and interfere with your network. You invested in infrastructure, you're using this network, you don't want to necessarily have it interfered with. So there is some level of control now. It is free spectrum, but you have to register and say, I'm using this spectrum here, protect me. that means you have to be connected to the internet. So that has caused some issues with some enterprise. They literally don't want their network connected to the internet in any way possible. So there is, if you're going to use CBRS, your network has to be connected to the internet. So when we look at what makes a successful private wireless, it's, again, they don't buy the connectivity, they buy an end-to-end solution. And this is, again, coming back to the folks on the call or in this room, we need everybody to be part of the ecosystem. It comes with spectrum. Right now you have free spectrum. We also at Nokia, realize the importance of spectrum, so we negotiate and partner and try and bring as much spectrum as we can to private enterprise. Edge computing is fundamental in our view of a private LTE network. That's what's going to make it work for enterprise. Access points, those are the devices and the type of radios. And again, you need different solutions. There's small picocells, and the reason for the different solution has more to do with cost. So if I want a small area, low capacity network, I want the cheapest cost possible. So the market is developing low cost solutions that fit what you're asking for. If you want a large macro network to fit your yard or like the utilities to go down their line, well then you need a high powered, and if you want video on it, you need a high powered, high capacity radio. They're a bit more expensive. So you need the ecosystem of different devices. Applications through application framework. What we're talking about there is we've taken our edge compute platform and we partnered with AWS, Azure, and we have all their IoT capabilities on there. But what was missing is that low latency compute power application on premise. So Nokia wasn't really in the application side of the business, but there was no mission critical push to talk, push to video application that we could put on the edge. It didn't exist in the market. The companies that did have cloud-based solutions couldn't make it work on an edge compute platform. So we developed our own push to talk, push to video for that purpose. We have a drone solution, and it's a public safety drone solution for search and rescue. We have high accuracy indoor positioning solution. So there was some gaps in the market that we had a live customer that was pressuring us to solve their problem, and we couldn't find the application to make it work. We had the connectivity, we had the network, we couldn't find the application. So we've developed a few, but we'd really like to find an ecosystem of application providers that can integrate on the edge platform and bring a differentiator. And then devices. So sorry, I'm running out of time and talking probably too much. I wanted to get into what I was talking about earlier is each vertical comes with their own use cases, and it takes the third party, the software, the device, and then you have to integrate all these things. So, and we partner with service providers. We have an industry ecosystem. So we partner with OCSoft for the wind turbines, Omron for automated guided vehicles and robots, and system integrators play a huge role, by the way, in enterprise industrial 4.0. And we don't think you need to wait for 5G. 5G is a sexy word right now. Everybody goes, hey, I want this private network, I need 5G. And then when we actually dig in and go into use cases and look at requirements, they don't need 5G. Some do, but I wish more of them did. So I'm going to go through quickly the manufacturing. Again, the drivers here is not connectivity. They have reasons why they need a private network and what they're trying to solve. And these are the areas that we're working with right now. So digital factory campus, digital twin, facility management, and smart connectivity are the use cases that they're implementing. Machine-to-machine communication, and really the machine-to-machine communication is more how to make a legacy device. And this, anybody that's involved in IoT, you need to access the data. Some of these machines have that information, but they're not transmitting it because their legacy machine didn't have systems. So connecting a legacy machine to pull the data to then do data analytics, that's one of the big drivers right now in this area. And then we have connected workers. I think that this is a cool one to me. I like what the connected workers doing. You know, having all this information bio, but also the safety glasses, the real wear glasses, the Google glasses. Yeah.
Ray, are you seeing applications now with social distancing and COVID for the connected worker to kind of make sure people aren't fooling
I've seen
things like that?
I see the solutions. I don't see the POs.
Right.
The
I'm a marketing guy.
industry,
That's what I like to talk about.
the industry has developed solutions, including us, but very few people have. The ones that are doing that will do that. It has nothing to do with COVID. So oil and gas.
Right.
Oil and gas is adding a lot connected worker because their employees are in unsafe environments. So they want to know where their employee is going, where he went. If he got sick, did he go in that part of the plant?
Yeah.
You know, that's so from now that might change because I think there's it's a good idea, but I'm not sure if I'm ready to sign the check yet. So yeah, but not for social distancing because we were all supposed to be 6 feet apart. Whatever.
Hey, Rick.
Yeah.
That's a real good use case for healthcare. You know, that I've seen years ago. Are you guys seeing that too, where you can track docs and nurses in hospitals?
Again, we have the solution in the U.S. I don't focus much on healthcare, and even though I'm responsible for that vertical, again, it has more to do with budgets. How hospitals split their budgets is a little confusing. In Europe, like autonomous guided vehicles in Europe in hospitals is a big use case. Desanitizing vehicles, delivery of pharmaceuticals, and it's not happening in the U.S. And when we've approached some of our healthcare facilities or hospitals, it's the IT group doesn't have the budget; it just executes the budget. The surgeon group does this, the administration does it, and it's all fragmented, and that it gets a little challenging. So I would like to see it happen, but I haven't seen it yet.
Do you see competition coming from some of the low power networks, like LoRa and others? Do you see competition coming from those?
Not for what private LTE is. So meaning, like we're doing a deployment right now where, like in ports, LoRa is still there, and it's still doing what it's meant to do, but it doesn't do high stream video from the crane. It can't. So we don't see private LTE as a competitor to LoRa. We see it addressing completely different use cases. And the other area is smart assets. It's fascinating to me how large industrial locations, manufacturing or oil and gas, they lose the machinery. They lose. We lost 5 forklifts. We have no idea where they are. It's kind of, it pays for them to be able to implement something like this where they can actually track it. Actually pays for the system because those forklifts are, especially autonomous guided vehicle forklifts, are not inexpensive.
So a question from online from Sunil Kandani. Can you please elaborate on control the network? What aspects of the network is the customer, like utility, able to control in a private network? So what do you mean?
Radio coverage. So where they want radio coverage, where they want capacity, and then quality of service at a either IP level or APN level, meaning if I have 20 use cases that are using the network, being able to prioritize which use case gets not just radio resources, but also, remember, it's becoming more of an edge compute type solution now. What gets the edge compute resources, and in peak periods, they can shift it. In other words, on Monday morning they arrive, they had it all structured and organized. There's a storm that occurs. They need to change it, make sure that whatever application they want is secure. They can change that at that moment themselves without calling anybody. And by the way, the other aspect of what they can control is their data. If they don't want their data to go leave their premise or their network or their firewall infrastructure, That's the biggest area of control. So these are some of the use cases that have been deployed. Like these are actual solutions that are beyond the PowerPoint slide, beyond the concept. They're actually ones that are the market is seeing value in. The other area in manufacturing I find is interesting is the workers that have been there 20, 30 years are leaving, and the new replacement resource staff is not necessarily not trained, but there's things about this machinery that isn't in the textbooks, isn't in the training, that they have to find a way to capture that individual's knowledge. And they're doing that through AR, VR, and just watching that worker, what he does during the day. Instead of asking him to get off the line to teach 5 guys how to do this, and a lot of times those guys don't want to train anybody else either, so they don't even have to ask him to train. They just say, hey, you got to wear this little helmet now, and then they train this. I saw that. That's an interesting one. And then, so I got some more details on actual use cases and what you need to do it, and I could share later on, but I'm running out of time and I want to leave for Q&A. Like it's not like I have the level of detail of what that includes, and that again I go back to the IoT aspect of it. I think there's more progress that can be done in how you implement these solutions by now knowing that you have Ethernet connection, you have a fiber connection, but now you can cut the wire. For those that are involved in IoT, I think you can start thinking about a solution differently, knowing that you don't have to worry about the fiber or the Ethernet.
It's like you had like 3 hours worth of material.
Yeah, I'm sorry. I do. I have one per vertical. I'm trying to get to another. And by the way, these are stats on implementing, because what they want to see is the dollar value. They don't want to see how it works technically. They want to see how it works business-wise. How do I pay for this thing? So in each of these use cases, we did the analysis of how does it pay for itself. And I want to get to warehousing. So warehousing, we've identified these. Now, I have to say, these are not necessarily the ones that they're buying. These are I just had time to put the slide of all the potential. But the ones in warehousing that we're seeing has a lot to do with, again, the same ones. Autonomous guided vehicles, tracking assets, and the cool one I like is actually here in one of the warehouses, they're using drones for inventory. Indoor drones for inventory. I think that's pretty cool.
What, literally counting their parts?
They're going to shelves and they can see the SKU.
Yeah.
So they're going back to make sure that somebody didn't take it and move it somewhere else, and it's actually where it's supposed to be. So it used to be you went and scanned, manually scanned. Now they send a drone to it.
Wow. So is that like a preset thing, Ray, or is that like real time somebody's flying that thing, or is it?
Well, what you do is you give it a route. You set the drone's route.
So it's preset.
Preset. You can change it. I mean, you have somebody that's monitoring the drone, but he's not driving it. He set the route. And then in schools right now, the last 3-4 weeks, all I've been doing is K through 12. It's been just phenomenal the amount of schools that are looking at providing broadband to the students, the whole e-learning, and we're looking at different models. But in universities, we had seen progress at the end of last year. Universities are deploying right now private LTs, but mostly for their faculty or engineering, or to learn about it and to talk about the technology. And last year they were starting to look at operational implementation. COVID kind of just put that on hold. We have a couple of trials that just keep moving month to month to month. One of the big ones is the blue phones, emergency booths. Some of our wireline carriers are cutting the service to wireline because really they're just a phone booth. But you know, I think at the University of North Carolina, we're told that their blue phones are going to be service going to be cut. So they're looking at alternatives for flu phone. So that's one of the big use cases.
The flip side of all that is all this remote education stuff is just blowing up access. I mean, it's unreal.
Yeah, and that goes back to, again, it's not about just connectivity, because when we're talking about the K through 12, we're talking to them, what application are you going to want your students to see? Oh, why would I need to, I just need the pipe. No, you have to think about what you're going to use, what software you're going to use, what application. And for example, that company I told you about earlier, Radiant Images, they worked with Harvard Medical School to control the video content and also manage it if they lost bandwidth, so that you didn't lose the session. And if you did lose the bandwidth, lose the video, don't lose the voice, stuff like that. So you have to think about the application as well. And then in the ports, again, pretty much the same use cases, but I think I've gone over my time. I just wanted to show you again, in the ports, it's about the business side of it. It's where's the dollars, what am I going to save? And this is an example of attaching a use case to a business driver. I think all of us in the industry have to do that. So
You need to schedule another session to go through all these things.
yeah,
So anyone that needs to leave, feel free to leave. Anybody that wants to stay for Q&A and continue on with the presentation, you're welcome to stay. We have room till 9:30 officially, and then we can move to the common room for our networking. So take it away.
okay. So I just wanted to talk about video analytics too. This, to me, is a large use case in many verticals where they want video, but they want to cut the wire. One of the large shipping companies, package companies, have massive yards with their trucks, with inventory and packages ready to go, and they have it all on video. They have security walking around. But what they've noticed is that the thieves or whatever would figure out where there was a gap in the
Blind
video,
spot.
a blind spot. And for them to move the video cameras was just too costly. And so now they've purchased a slew of portable cameras that they go and move around constantly. And they're trying the drone thing with the thermal camera, but that they like, what they like is being able to move the video camera, and then add the analytics to it. Because they move a camera, well, there's bobcats and coyotes and dogs, and they want to be able to they didn't hire 40 security guards to look at these cameras. They only have a couple guys, and they want to be able to pick up what's real.
Yeah.
So,
there's companies that write algorithms that determine what a man looks like versus a bird flying through.
Our friends at Bell Labs.
Yeah.
And so talking about COVID, that was one of the first ones I worked on. I called the guys at Bell Labs and said, hey, let's get ready for this. Being able to track somebody who has a fever. We put so much effort, so much work. It's not really being. The basic is meaning walk into a building, somebody taking your measurement, or walking to a camera, a thermal camera, and getting measured. But we had developed really cool algorithms of what you could do after. When the person is measured, where they went and who they talked to and how long they talked for, and you geofencing it. And again, we have a solution. There's nobody that's. We have a few government agencies that are interested, but other than that, it could be cost. Again, we have to justify the cost.
You might sell that in Russia and China, maybe.
What's that?
I said you might be able to sell that in Russia and China.
Oh, we do. I won't get into politics. You almost did. You almost had me. That was good. Like I said, our government is buying. I said enterprises. Video analytics. I think that's a huge one. And again, we need more creative ideas of what you can do with video analytics and IoT applications to show the business value. There's some cool stuff that we can do, but what we're lacking is a little bit of ideas that actually generate revenue for companies or cut their costs. Security it's a strange animal, security, because they will pay only as much as they have to. Oh, this is the doing video analytics for inventory. So the drone is an example. This is for ports. They will send either autonomous guided vehicles or drones, and they'll take inventory. They lose so many of these, some ridiculous amount, like 5%. 5% of these, they're in there. So they're somewhere on a ship or in a warehouse or in a different country. You have no idea. It's crazy.
That's a lot of containers. That's
Huge
a
amount.
lot of containers.
Yeah. I was surprised at the number. I thought, that's a typo. There's got to be a zero somewhere in there. But no.
Even 0.5% would be an enormous number.
Anyway, so that's we're working to see how the drone one is a good one. So we are now the drone part is at first we didn't want to get into the drone business because there's plenty of drone companies out there. But what truly was lacking was the real-time drone, high definition, thermal camera, like the higher end real-time drone. There really wasn't many solutions out there, mostly because there's not a big market for that type of drone. It's an expensive drone, and really it's not a hobby drone, so there wasn't a large market. So companies that are in the drone business weren't focused on that market. We have a YouTube video. You want to see it? I think it's really cool. I like it has a base and it's white and it shifts open when the drone starts getting close. It knows to open, knows to close. Just looks sharp to me. I think I said there. Tried to make it as interesting, but if you have questions in regards to, I call them the in-building verticals. That's where I focus. So hospitality, healthcare, higher ed.
Stop sharing real quick. Thank you.
Good. Please.
I'm still thinking about video analytics, and I know like wired legacy camera networks are like really a pain. So there's value in portability, and then there's value in video analytics as well. But what about the cost difference? Does it make, with just the convenience of portability, does it make business sense, or is it the AI and the algorithms in video analytics that have to like literally save, if we talk about surveillance, for example, they have to save stuff like pilferage and whatnot. So do you think the value comes from there?
Well, on the value side for cameras, the cost of cable. So the reason they weren't moving their camera is it was too costly for them to always move their Ethernet cable. So from a cost standpoint, if you need portability or mobility of your cameras, then the value's there. From an AI and a video analytics standpoint, they're all a little different, meaning what's the application if you're going to use the analytics for? So we've come up with analytics on, let's say, slip and fall or highlighting. But then can you eliminate a security guard if you're implementing AI or video analytics? If you're not, then you're not really saving any money. You're making it more efficient maybe, but so you have to look at the application and go, like in oil and gas, they're using it for geofencing. But there's a debate right now because you can also do tracking through just the device. You can do triangulation and then tracking. You don't need video. Video may add some features, but from a cost standpoint, most of them are just deploying the non-video geofencing because we haven't shown the value yet. Okay, good. Thank you.
Chris, do we have any questions from the internet?
We had a couple earlier. Back. And if anybody has questions on the internet, please type them in now. Let's see. There was a question about MEC function, if that was what we were referring to earlier. And then there was also a question regarding asking from Solomon Israel saying, help me understand a private network bias to large companies and large facilities. The key issue you point to is where the radio is placed why wouldn't Wi-Fi suffice?
Oh, Wi-Fi could be the right solution for that use case, but mobility would be one, like AGVs. AGVs in a mobile Wi-Fi environment stop. They wait. The handovers aren't as fast. Sometimes it's interference. So there are possibilities that Wi-Fi is the right solution. We're just dealing with use cases where Wi-Fi wasn't sufficient. And sometimes it's a cost. If you're doing a 3 square mile plant, outdoor, indoor facility, the amount of APs required, remember, LTE to Wi-Fi is usually 1 to 5 or 1 to 7 APs. So if you're doing we did a pulp and paper mill, massive, yard, they would have, and they do the Wi-Fi design, and then they compared the LTE design to a Wi-Fi design, and the amount of APs was 1 to 6 or something like that. So there's a cost implication as well.
Meaning fewer APs required for LTE.
Yeah, for 2 reasons. One, power. You can at some bands and some frequencies you can transmit more.
Yeah.
And the other one is the way LTE was designed. It is better at the edge for interference and actually uses interference sometimes to help with packets.
So we had an online question about security. Are private networks, it's from Yvonne Salazar, are private networks easier to hack than carrier networks? Who's responsible for private network security?
And so the main aspect of private network is, the SIM technology is the same on both. I would say a private network probably has better knowledge and access to the subscribers than a public network, but then you're going into the enterprise's IP network as opposed to the carrier's IP network. So it's only as robust as the IP that enterprise's network. So if I was going to compare a carrier network to a utility network, I would say the utility network is probably more secure than the carrier's network because they don't have a shared network, and a carrier network is a shared network. So there's certain things they can't implement for ease of use for their subscribers, where an enterprise can add security protocols much more stringent, but that doesn't mean they will. So
it becomes security through obscurity sometimes.
Yeah, right. So if that enterprise itself has no clue how to secure their network, then hey, it's free open game.
Right, so are you guys promoting your NSP as a services management system for private LTE?
NSP? Oh, for larger networks, I think the utilities are using it, but not for most enterprises.
So it's the smaller ones. It's not cost effective. It's
not cost effective or required. They don't want a whole bunch of dials to turn, and that's what an NSP.
Richard.
Yeah, I'm not asking questions. I just want to add a couple of comments. I've been working for the private IoT network for a couple of years, but not in Nokia, but exactly the same sector. Actually, there are some kind of more interesting user cases as what we have shown. Like actually, we used to. I mean, my previous company, we used to work with like array bus terminal. Okay, the application is that when the bus after the bus goes out and come back to the terminal, and they have a video all the way, right? They took the video in the bus for the safety or all those reasons, and they have to upload those videos in a very short time when the bus still moving into the terminal and do all the cleaning, all the works, and then they have the bus has to go out again, right? In a very short time, and they have to upload a huge amount of videos. I think real trains will have the same application needs, right? And in that case, okay, the public LTE network bandwidth is not enough, and Wi-Fi cannot support the mobility. So in that case, they do have interest for this kind of like private network, LTE network, so that they can meet both the security, mobility, and the upload data rates. Just to give examples. Okay, just a comment.
Yeah, no, agreed. Absolutely.
Ash, did you have some?
Oh, no.
Okay.
Ray, are there applications where private LTE networks interact with the public LTE network? I mean, either for the wide area, you talk about the port or the mine, that truck leaves the mine, does it now like roll onto a public network? Is there
there are scenarios like that.
I mean, are you
It is
deploying them,
possible.
or it's just
It's not a technical issue, it's a commercial issue.
Right.
I mean, there are, and actually, I think our wing platform is an example of that we have a global, where we have global IoT connectivity through the carriers. A private network would then have a dual SIM capability.
Right. So I know it's technically feasible. Do we have any applications of it yet? Or
Yeah, I think a lot of them in the ports.
Yeah.
There's one, and then a bottling company, a global bottling company. Oh, and actually just the auto manufacturers. The auto manufacturers are putting private LTE networks in their plants, but then those vehicles, when they get shipped,
right,
and they turn up, it's on the public network. So that would be examples of it.
Thank you, Ray, for coming today. I saw Vaughn Hamden came in. Vaughn, would you like to say a word and welcome everybody?
Thank you, everybody, for coming to Texas today, and I'd love to have everybody around, and if anybody would like to later see the building, I'm willing to go around and show you, but thank you. Hopefully this will be the first in many, many times.
Thanks for coming today. We'll see you next month on the 18th. All right, thanks for coming. Thanks, Ed.